Now, in V2.1, you're asked to find, if indeed it's possible, an Eulerian circuit for each of the following networks. When there isn't one, find, if possible, an Eulerian path. Now, after a bit of repetition, we will find some possibilities here. It does take trial and error, and indeed some patience. Now, I can go, in this instance, from A to E, and circuit around like so. There are a number of other possibilities, of course. In this next instance, a little bit of trial and error. Every path, or edge I should say, has to be passed or transited once and once only. So you can see I've got from A back to A in both of those cases. In the last instance, I don't think I can. I think I'm going to strike a bit of a problem there. I'll start at A and see where I end up. No, it's not possible. I'll get a little bit stuck. I can, however, start at one of these two vertices that's of an odd degree and travel every path once only, but not get back from whence I came. So starting at E, C, B, A, E, and I end up at C. Started at ended up at C. An Eulerian path, an Eulerian path. Eulerian circuits existed for the other ones. Now please note, in a test or an exam or assessment situation, you will have to write down your path. So I'll list some examples underneath. And please notice there are variations of these, although with the Eulerian path a bit more restricted. An Eulerian circuit, when we travel each path or each edge once and once only, starting and finishing at the same point. An Eulerian path means that each path or edge is passed or travelled on, once and once only, but we start at one point and end at another. Please take some time to look at these problems, and there is a bit of a rule here that will be very, very handy. C and E in this last one were both of an odd degree. The fact they're both of an odd degree and the others are even meant an Eulerian path. In all the other cases, each of the vertices were of an even degree, which means that an Eulerian circuit is